So yeah, 6 months ago, I found myself working with Kafka, with some Java devs. I work for a gambling company who have sport data going through on a Kafka topic, and that basically updates their website. So I was asked to join this team where they were building these Java services, but we had an existing JavaScript library that I needed to use for our test data, and I had to use Node and Avro, and this is basically just a kind of like lessons learned / introduction to Kafka. If you find yourself using it, maybe this would be useful for you, but essentially what I'm going to cover with this. So pretty much it's going to be what Kafka is and its key concepts. The last time I did this talk, it was ridiculously long-winded, so I'm going to try and keep that as short as possible and show you some actual code, because there's a lot of stuff I need to cover on that one, and then dive into more kind of like the JavaScript side of it, so what Node libraries you can use, how to use it with Jest, some stuff that Jest gives you that makes things a bit easier. But yeah, first things first, I guess, who I am. So yeah, I used to be a dev. I decided to join testing side of things because that was a bit more interesting to me. If you want to check out my CV, it's there. It's very boring, I guess. Right, cool. So Storytime. So yeah, as I say, I was working for this gambling company. They moved from this kind of like system that essentially replicated a database and then sent over kind of like slices of a database over to this more kind of like streaming system. So that meant that they went from being able to kind of determine what was going to be in a payload to it potentially being on multiple nodes coming at different times, and it was just a massive pain to kind of get their head around. And I was asked to build an automation suite to test that when we put one thing in one end, it comes out the other end, and in between the messages are going into the right topics. So the kind of thing that I was dealing with was, you have an API call that says create this event in a sport. It goes to this app. This app then goes and serializes that with Avro onto a Kafka topic. Kafka topic then gets picked up by this adapter app that then kind of takes it and goes, okay, it's this type of thing. Maybe we need to create more messages. That creates a bunch of other messages that aren't Avro serialized, and I'll get into that later. And then that goes to the consumer app, and eventually the website takes the API from that. So when I was building my test suite, I had to find an easy way of testing that I could say, create an event with 5 markets, and then 5 markets come out linked to the event in that bit. So what Kafka is. So I'm going to basically regurgitate some stuff on Wikipedia. I believe there were some people from LinkedIn that created this kind of streaming, high throughput, low latency distributed message queue. It is essentially a streaming message platform. It's used by a fair amount of companies these days. I think it's kind of started to replace things like ActiveMQ and Rabbit and that. But essentially, it's an Apache project, so a lot of the Java devs like to use it. And more importantly, there's a company that there always is, that is the original developers who are trying to make some money off of it. And Confluent have some really good tools that I'll kind of touch on later. So let's just get into this horrible bit about what everything is. So you have a producer, you have a consumer, and you have a topic. That's the key concepts. I'll just try and kind of go into a little bit of detail about which is. So a producer produces messages to a topic. It covers a lot of things about kind of like being able to serialize a message. So serialization, which is what Avro is essentially a way of converting that message into a separate format. So Avro, for instance, will convert it into a binary format. It saves some space, but it also has some extra bits that are apparently really useful, but I've never really seen it. So try and not be biased on that, but essentially, yeah. You will say, for instance, create an object, and then you'll produce, like using the producer, you'll publish this to the topic. The topic could then be on multiple nodes that could be anywhere in the world, and eventually a consumer would then kind of connect to that and grab the messages off of it. So this is what a consumer is. So a consumer reads the messages. It will also deserialize. So for instance, if you have used Avro and then you have what's known as a schema registry, the schema registry has like a kind of, it's essentially like a set of instructions on how to decode the message from the topic. So a consumer needs to have access to that. A consumer also has a thing called a group ID. So for instance, if you're trying to test Kafka, it's really useful to have group IDs, because when it comes to things like rejoining a topic, when you have to kind of like consume fresh messages, it's a lot easier to basically create a new group ID, because that will have no memory. The Kafka broker itself will store the kind of offsets for the different messages based on a group ID. So by creating a new one, it will just kind of go, I don't know who you are, and give you the latest if you ask for it. And then a topic. So as I say, a topic is kind of like the stream of messages. The topic is the bit that gets partitioned. So you could have, say, 11 different Kafka brokers. You could then split a topic across all of those 11. And then based on your kind of like partitioning strategy, you could have, you know, them all kind of replicated across the 11, or it could be that 5 of them have it first and then it slowly kind of filters out. And you kind of need to be a little bit aware of that. But essentially, what you can guarantee is that, you know, you can subscribe to a topic and you'll eventually get that message through. It can kind of get a little bit dangerous sometimes if you don't have the right number of topics, so you have to do that whole kind of like quorum thing to make sure it all balances out. But essentially that comes down to this partitions bit. So yeah, essentially the partition is kind of the Kafka broker's versions of that topic. So for instance, if you have a Kafka broker and the topic's on there, and then you've got a consumer reading from said partition, then ultimately the consumer's group ID is what that partition is going to use to bring back the messages. So coming back to kind of, you know, the whole easiness of using group IDs, if you need to, for instance, kind of like, say your consumer dies and then it comes back up, if it's got the same group ID, then that partition will go, okay, this is where you left off. But sometimes you want to make sure that, you know, if things have been for too long and you've got some alternate way of getting those messages through, you kind of need to re-roll that group ID so that partition's not going to kind of give you old messages. And then that comes back to offsets. So the offset is essentially just the message that the topic was on and the consumer was reading up to when it was, you know, reading messages off of it. It's really useful for things like, as I say, when things die, but we also use it for being able to replay data from certain kind of offsets. So for instance, say we want to get the last 24 hours of data, we might potentially know what the offset is for that and then use that to filter it in. So that kind of is a weird use case, right? Avro. Avro is this binary serialization format. It's, I believe it's the Confluent kind of library that, or Confluent company that produce it. The way that it works is that essentially you create these schemas, which is a representation of your data. Then you serialize said, like, you know, the messages you want to put on the topic with that serializer. That then gets put onto the topic. There's a schema registry that the consumer connects to when it wants to deserialize the messages. And the idea of the schema registry, again, try not to be biased. It never worked for us, but ultimately what's supposed to happen is it's supposed to be able that you can change the schema, and if it's not a breaking change, it should be backwards compatible. So then you end up with this thing where like the devs can go off and do crazy stuff and change the messages and all this other stuff, and then ultimately you know, people consuming the messages don't need to worry too much about that breaking. But as we've seen, it breaks a lot, and I'm not massively a fan of it. So yes, probably the most applicable part to you guys. Right, node libraries. So there are 2 node libraries that I was using when I was working with this that I found was really useful. So there's Kafka Node. So if you're not having to deal with Avro, Kafka Node is a really easy to set up library. I believe it's built on the RD Kafka Node binding that Blizzard, the guys that make like World of Warcraft and stuff, built. It makes it easy to kind of like create these producers, consumers, and you can also essentially like do some magic to kind of make sure that the consumer's group ID is set on the fly, which is really useful for the stuff that I was doing. Then you've got Kafka Avro if you need to use Avro. For some reason it's put this asset on there, but essentially it's kind of like a wrapper over Kafka Node, but with the Avro stuff in it, and it uses this AVSC library to do the deserialization. The only problem I found with it is that if the Java developers who are building the Avro schema happen to publish a bad schema, AVSC is not as fault tolerant as the Java libraries that people were using were. So we had a thing where one of the kind of like properties on the schema was an object as a string. So it was like string, and then the brackets to take the object. And that failed on AVSC, but the Java thing Java library just kind of said, hey, I'm never going to use it, so I don't care. So it didn't break for them, but it broke for us. So that's kind of like one little gotcha that you need to be aware of. You can use AVSC to pass the schema registry. So I'd suggest if you start to pick this up, probably just use that lower library to make sure that the schema registry is passable. Because otherwise you find yourself in my situation where you've got a bunch of people moaning at you because your thing's not working, but their thing does. So Jest. I love Jest. I used to use Jasmine, and I know that Jest is built around Jasmine, but I really, really prefer Jest these days. Test environments are an amazing thing. So what we were using was essentially, like a before all. And what was happening is that we then had to kind of like extrapolate out, from one kind of, it's trivial, it kind of works test case to 24 of the things. And what we were able to do with test environments was to kind of have like a setup. So in order to get the consumer subscribing from the Kafka topic, that we were going to ultimately have to read messages off to validate that the messages were correct, we could bung this setup code into this test environment. And then that allowed us to kind of just write tests that were like assuming that these messages were going to be in a global object somewhere. And then we could go off and, write very simple test cases, fully aware that the kind of like setup stack was actually there for us already. So that worked really well for us. Yes, but the only other side effect of it is that Jest by default has a 5-second timeout. Now Kafka's all proper asynchronous messagey stuff, which means that ultimately you may find that sometimes it takes more than 5 seconds. So your tests may fail because they don't receive the message in time, especially if you've got like latency over networks and stuff. So using a Jest setup file allows you to set a high timeout, and you can also do this with like a config value. So for instance, say you want to have your tests bundle into a Docker image pushed to like 5 separate environments that may have separate rules to them. You can then use environment variable on a Docker image to kind of set that timeout. That's essentially the way that we did it anyway. And that meant that when we had like a development environment that had no data in it, or like very little data, we could say, all right, well, it might take 30 seconds to happen. But when we had like a production system that had loads of messages pinging through, and it could take up to like 2 minutes for our test suite to kind of like get this data, it meant that we could control that easier. So yeah, as I say, like the test side of things that we were doing, we had a lot of essentially, that's better to say. So we had a load of messages in a queue. We had to wait for the message to arrive onto said queue, and then we could do kind of like checking that the JSON was correct and stuff. So the way that we started to look at this was to start with polling instead of like. Some people, I don't know if you've ever come across this if you've ever done automation, but some people, they like to put these hard timeouts, so just go, assume it's done in 10 seconds. Polling allowed us to get away from that. It sped up the test suites. It also meant that we could use this pattern everywhere. For instance, when we needed to wait for servers to be online, we could use it. Whenever we needed to wait for the REST API to be updated at some point, we could rely on it, and all we had to do was make sure that there was a decent timeout for it. So essentially, I'm assuming most people have done it, but you ping something, you say, is this condition true or false? If it's false, you then wait a bit, and then you do it again, wait a bit, do it again within a reasonable time period, and then eventually, if it is true, you return the data or the object or whatever that you're hoping to get out of it. Similarly, you can rely on filtering. So if you've got an array of 20,000 messages that are coming off this queue, you can filter out the messages that you need to work with. So you may find that when you're writing your tests and you're with the example I was talking about before, where you send one message and that results in 6 of different types. Ultimately, you can use a filter to filter out all the messages that relate to one particular entity or process or whatever. So array.filter was really useful. We used array.filter, we used array.find, and then we had MapReduce as well in there, just to kind of like chain all of this together to get the exact kind of like messages that we needed to take off the queue, and then do our kind of like checks against. Yeah, I mean, I guess everybody knows how array.filter works, right? I don't need to go into that. Awesome. Okay, so this is back more to the kind of Kafka stuff now. So CLI tools. If you don't want to have to write JavaScript-y awesomeness to try and kind of just make sure that this Kafka stuff is working, you can rely on some CLI tools. So Apache and the Confluent guys, they offer these CLI tools for it. So you've got consumers and producers. So for instance, say you have a Kafka topic that you want to make sure that your tests or a downstream system is receiving messages from. You can use a producer to connect to it, type in like the payload that you would expect to publish to it, and then basically publish that and then make sure that comes through. Similar with the consumer, you can connect to the topic and make sure the messages are coming through. If you set the group ID on the consumer to be something different than the one that your downstream app is using, then you'll see like all the messages without affecting that one. If you end up using the app's group ID, then you run the risk of essentially taking a message from that app. So it's pretty bad. Don't do that. But these are all terminal commands that you can run. And Confluent offer this kind of like Avro-based consumer and producer, which is great for the consumer because you just have to put a link to the schema registry. Bad for the producer because you actually have to put the Avro schema onto the command. And if you've got a massive Avro schema, it can be ridiculous. So yeah, I'll be a little bit wary about using that. Also, if you find that you need to send data from an existing Kafka queue, so say like you've got a topic that's got 1 million messages on it, and you want to replay all of those messages into your app, it might actually be better to use this Kafka Mirror Maker tool, which essentially reads messages off one topic and puts it into another topic. And then within that topic, you can have like you could say mirror it to a local version of Kafka, and then replay it from that version. That just means that you're not having to go over the network all the time. It makes it a little easier. And you can also mirror make it into things such as, with my example of having to deserialize and then send on the messages, you could mirror make it into the deserializer app, then basically take it off of that and put it into another topic, which is the deserialized version, which means then the app that reads that message can get those messages without having to go through all the deserialization process again. But yeah, as I say, it reduces like this heavy load that you might come through if you go through via the internet. So running locally, so this is mostly now demo time and hopefully some code. So what we were using Docker and Docker Compose to build essentially a 15 microservice like stack, which would then connect to an external Kafka queue. That then meant that we had like an internal Kafka to that stack, which was the bit where the deserialized messages went. So it was quite easy. We could just use like a Docker Compose up to get this entire stack coming, and then the services themselves would then start connecting to the Kafka queues, get the topics, get the messages off of that and start running. But one of the things that we found was that with the Kafka is that when you run it in a Docker image, it needs access to the host IP. For some reason, it kind of like wants to talk outside of Docker back into itself. So we had to write like some make scripts that essentially kind of get the host IP and then send that as an environment variable down into the Docker so that it actually can talk to itself. I think it's mostly to do with Zookeeper and how it keeps itself like stay alive and stuff. So yeah, that's just a gotcha. Right, this is the fun bit. Okay, so example project. I've built an example kind of like Docker project slash JavaScript project slash, it's got the Jest tests in there and stuff. So I'm going to attempt to show this to you. If it all fails, then basically you can go to github.com/gitnig, testing Kafka app with Jest. But essentially this is going to replicate what I had to deal with. It's going to be not a gambling app, it's going to be a healthcare app, but essentially it replicates sending a patient into a ward and then moving them around, and then the messages that go with that. So, this is bad times. It's going to be bad times, isn't it? Right, come on. How do I send you to that? Is this that way? There we go. Cool. Yeah. So hopefully everybody can see that. Do I need to increase the size? Yeah, okay. Now I need to remember how to do that. Can I do, is it like option or something like that? No, that does not work in the terminal. I know it works in the code. Ah, well. Alright, well just imagine that you are seeing me say make run, and what make run's going to do, in fact I can get the make file up here, can't I? Alright, I think I can do that, there you go. Is that a bit better, or do I need to go bigger? I think that's pretty big, right? So here's that host IP thing, so that's just going to do some nasty ifconfig stuff to get my IP address. It's then going to run Docker Compose up for a bunch of Confluent services. So this is things like the schema registry, the original, like the initial Kafka. It's then going to run these bash scripts, which essentially, one is that polling thing that I was talking about. So it's going to poll to make sure that the schema registry is up. Once the schema registry is up, it's going to send a post request with the schema registry for my messages I'm going to be sending. And then it's going to create a topic. The topics, topics, because there's two of them. One's going to be to do with patient, and one's going to be doing with patient movement. And then it's going to bring up a separate stack, which is actually my app. And the reason I do this is because until the schema registry is set up and the topics are set up, if I bring my app up, it can't connect to them and it breaks. So I need to kind of do, like a bit more complicated setup. But hopefully if I do that, and then if I get, where's my mouse? There we go. If I get this guy over, come on, what are you doing? No, that's just gone behind it, isn't it? Yeah, okay. So that should hopefully, no, come on. There we go, cool. So has everybody used Kitematic before? Aware of it? It's a really good thing for finding Docker stuff in Mac. It just allows you to see the logs of the various different apps. So for instance, I've got my adapter app here, so I know that's started up. I've got my consumer app there, I've got Kafka, etc. But yeah, this is make sure that things are running smoothly. Cool. So at this point, I've got my my stack running, so I should be able to just like send some post messages over to that, and it should all work. But really, what I'm going to do is I'm going to write some tests to do that, because that's a little bit easier to do. So the type of tests that I've got is, I'll show you the test environment. If I can zoom in, come on. This is painful. Right. So essentially what I was saying before about Jest test environments. So it's just a file. It's a file that's got a name, and then when you go into your test case, such as like discharge patient test case, at the top here, you, come on. Oh mate, come on. There we go. Cool. Yeah, so you've got this bit here, Jest environment, and then you link to the file. And what that says to Jest is basically when you're going to run these tests, you're going to run this bit of code first and set up the environment. Like, for instance, here we're going to go and that's all boilerplate code to set up consumers. Here we go. Right. So we're going to create consumer app inbound messages on the global, which is just going to be an array. We are going to set up producer outbound messages, which is going to be an array. we are then going to await. So this gets the consumer. So this is essentially saying, for my consumer app, here's the inbound topic. I'm going to create a consumer that's going to listen to messages off that. And then I am going to, on the message coming through, I'm going to put that message, pass it, but then put it onto that consumer inbound messages on the global. And similar with the producer thing, I'm going to get a producer, and then when I get some data from that, I'm going to push that too. So now I've got two, in my test set up environment, I will have two global variables that represent the two messages, two topics of messages coming through from the different apps. So this is like in the middle of those two. And then in my actual tests, all I have to do is, right, let's get that, there we go. So all I have to do is, I've got this method here called eventual queue member, and what that basically does is it polls that array for a message that has this NHS number, for instance, and then once it finds it, it will go and return that as this particular adapter app transfer message in here. I've also got a filter function, so I pass this function through, find second inbound transfer message, and what that is doing is essentially just kind of doing some additional checks to make sure I've got the right message in my filter function. So essentially, the actual app, the actual test itself is it fires off this admit patient function, which essentially just sends a REST call to the first part of the app. It then goes and waits for the message to come through on the topic, and then finally, after that, I go and make sure that it's in the API of the end app, and then within there, I go and check that the messages are correct. So at this point, I've kind of sent a message through the entire, I've sent a REST API call to the kind of like producer app. The producer app has sent that onto a Kafka topic. The adapter app has taken that topic message off, deserialized it and sent it onto another topic. That topic has then been consumed by the consumer app, which has then updated the REST API. So it's gone through the entire application. And now I'm doing all of that in my before all, and then my actual tests are just pretty much making sure that all of the messages, so for instance, that the discharge message that's from the producer app is correct, so it's got the correct properties, that the NHS number in that message is correct, that the discharge date is correct. Then the adapter app has taken that from the Avro serialized Kafka topic, and then done what it needs to do with it. So for instance, it's put this onto the other Kafka queue as a deserialized object, so making sure that that's all correct. And then finally, with the API endpoint, so made sure that the REST API is actually returning the correct data. That's a little bit more than what we're doing at work, essentially. But if I now press this magical play button up here, hopefully you can kind of see some nice green ticks, and then I'll show you in the logs what it kind of looks like. Come on. You can do it. Don't fail. Sweet. Okay, so that was, I won't make you sit through all of it. So yeah, in terms of the transfer message thing, so what we've got here is a console log of the message that it found on that Avro Avro serialized queue, which essentially is some nasty JSON. Then after that, it takes the message off of the non-Avro serialized queue, which is this one here, and then it checks the actual REST API endpoint. Yeah, that's basically a demo. As I say, if you really want to muck around with it, go on my GitHub and have a look at that, because that's probably going to be a bit of an easier way to get to grips with this stuff. Feel free to break it. If you do break it and you find a way to fix things, then by all means submit a PR. But yeah, that's pretty much all I've got to say on the subject. So pizza?